Hey there, so in this video we're going to go over the concept of composing functions. So in the last video we had done something where we worked with the put-if-absent method in a hash map. This time we're going to look at something along the lines of a hash map which contains as a string its key and a set of strings as its value. Now much like hash maps, you have to use a implementation of the set interface. The set itself is not going to work. So we'll go with a tree set, which would be a binary tree, pretty much left and right. So to start this out, I've just got a basic hello world program with main in it. And I'm going to put in a hash set, or a hash map, with string. And if I put in set here, you see a whole bunch of different options: hash set, bit set, linked hash set, tree set. I'm going to do a tree set. I'm going to make it have a string as its type. Alt-Enter on Windows or Command-Enter. Well, Alt-Enter on either operating system will import the imports for you in IntelliJ. So my need set equals new hash map. We'll use the diamond notation. So what we're going to need to do here is it'll work very similar to how you would typically work with a hash map, where you can go put myNeedSet.put. But now it wants a tree set as the entry inside, so we could go hi there and then new tree set. And that would work. There's not going to be anything in there. So that works if you're wanting to later go in and say, if myNeedSet.get hi there dot equals null, then do something. And you know your program's going to do that, would work just fine. But more often than not, if you're doing this kind of composition, you already have a set you're wanting to work with. So what we could do here is we go tree set string, some tree set, and then we can take that tree set and do the add function on it, a string, another string. And we're just going to copy this second line a couple of times in for fun. And the interesting thing about a set compared to a bag or a multi-set is that a set will only have the same entry once. So if we were going in here, we go myNeedSet.put set of strings, and we go some tree set. We've now composed the function together. So if we wanted to print this out now, we could go for string s in myNeedSet.keyset system.out print line myNeedSet.get s. Because s is a key in the key set, we're just getting the key. So we go to get here, it tells us that it's going to take the key, which in this case is a tree set of strings. Awesome. If we run this, then we see a string, another string. But we put another string in 3 times. Okay, well that's fair, I guess. Let's change that out to cat, dog, bear. We rerun this. You notice that we have bear, cat, dog. It alphabetized it. That's because it's a tree set. So what if we were to change this over to a hash set, which is another type? We can see all the different types of sets that we can use by looking at the Java docs. First off, we're going to have an error here because we changed this to a tree set of string, but since we're working in the generic sense, we could tell it to take any kind of set string. We just can't initialize the set with a new constructor without telling it the specific implementation. That's the whole concept of is-a relationships. So a tree set is a set. A hash set is a set. Now if we go here, what we see is that we have a string, another string, cat, bear, dog, but they've come out in different order. If we run it again, it still stays the same order. It's because the hash set has a different mechanism by which it hashes the inputs to go in and puts them in an order that it determines based on the algorithm. Suppose we were to put in a linked set, a linked hash set. What would change here? We don't have to change our hash map, which is nice. We can just change out the type. Here we get a string, another string, cat, dog, bear. But we could technically go in here now and change this out the same way we could a linked list. So we could say linked hash set string set equals myNeedSet dot get s. But it's throwing us an error because it's expecting set. So now we need to tell Java this is not the generic set, but rather that we're trying to pass it the linked hash set by casting it. Now it's okay with it. So now if we were to go into this, then we could go set dot, and we can start to see all the information about the set. We can run a parallel stream on it, do multi-threaded work without having to do any of our synchronized code blocks. We can go ahead and see the size of it. We can run an iterator on it. We can do a for each. So we could do a for each elem goes to system out print line elem. And this will let us print out each element in the set. Now we find a string, another string, cat, dog, bear. But it says that tree set cannot be cast to linked hash set. They're in module base of Java Loader Bootstrap. I'm not sure what exactly we're running into here. Oh, we put a tree set inside of the first element, which is why we were seeing our second element the whole time. And now it's throwing us some errors. So let's just remove that. Let's remove this get call since it's irrelevant. We'll rerun this again. Now we have no errors, we get our data. So if we were to go elem dot lines, we can see the stream of strings. We can go substring 0 to 2 on each and only get the first few characters of each of the entries, just like we could a regular string. So this one's going to be A space, A-N, C-A-D-O-B. So any of the stuff that you're used to doing on strings works here as well. Same can be done with integers, same can be done with any type. And this is a very useful technique for when you're trying to do work in something other than an academic basis, because you're now able to put together compositions similar to how you would in mathematics when you think of taking the composition of functions f of g of x, or if you were to go ahead and realize that for every dictionary entry you have, there could be multiple definitions of the same word. This kind of thing is very ubiquitous. So if you have any questions, please leave them in the comments section of the video, and we'll do my best to answer them. Thank you so much.